Come Fly with Us allows students to experimentally test a variable and to try out and apply the steps of the scientific method that they've been learning in class. To start this class, I typically will engage my students in a conversation about the different parts of a helicopter and how they know that helicopters move. I'll even show a video clip of a helicopter doing a stunt flight so they can see the different ways that helicopters are capable of moving. And then for this activity, each student is going to need a pair of scissors and this sheet right here. This sheet has directions on building the paper helicopter. It's pretty simple. They're going to start by cutting out around the edge of the rectangle, and then they're going to cut just on the dotted lines. So once they have the rectangle cut out, it's going to look like this, and then when they cut on the dotted lines, they'll have a slit at the top. That's for their blades, and they'll have two slits, one on each side, that's going to allow them to make the body of their helicopter. So once they've got the slits cut on the dotted lines, it instructs them to fold A tab back, C tab back, B tab or D tab up. They're going to get this shape. And then these are your blades. It's going to be important for this lab that we are all folding our blades the same way. So I instruct my students to fold the black circle or the X back and the white circle or the Y forward. And that way, when I come around and I look or I glance across the class, I can see that black circle easily. I can make sure that we've all folded it the same way. They are going to be making a hypothesis in this lab about how these blades are folded. You want the students to answer the question, if I change the direction that the blades are folded on my paper helicopter, will it change the direction of flight for my paper helicopter? Well, if you've already talked about how helicopters move and the parts of a helicopter at the beginning of this lesson, students should know that it moves by the blades or by the blades spinning. And so when we're talking about direction of a spin, it's either going to be clockwise or counterclockwise. So I stop and I take an opportunity for just a couple of minutes of a mini lesson on the difference between clockwise and counterclockwise before we start our lab. I even have my students spin their bodies clockwise for me and then counterclockwise for me so that I can make sure they understand the difference between the two. And then I have them make a prediction. And we write this as an if, then, because hypothesis. So we start off, if I change the direction of my paper helicopter blades, then, and I let them have the opportunity to choose here what they think is going to happen. Then the direction of flight will change, or the direction of flight will stay the same because, and then they give me a reason for what they think. Once we have read our if, then, because hypotheses, we're ready to experiment. And because we've already talked about the scientific method, students know that their independent variable, what they are going to manipulate on purpose, is the way that the helicopter blades are folded. If they're folded with X up and Y down, or Y up and X down. They know that the dependent variable that they're looking for is which direction it's going to spin, or the direction of their flight. And they also should be able to start thinking about some things that need to be constant in their lab, such as where they hold their paper helicopter, how high they hold it, where they're standing. Now for this activity, the lab directions suggest standing in a chair, and I give my students the option for this. If students stand in a chair to drop their helicopters, then they have more time to see it spinning and can make a more accurate decision about which direction it's spinning in. However, some students don't feel comfortable standing in chairs, and so they are able in my classroom to do this from the floor. But we want students to hold their helicopter at shoulder height, and we want them to hold it at the T. And all they're going to do is drop and watch it spin. Now, as they watch it spin, they're going to record somewhere in their science notebooks or on a scratch sheet of paper which direction they saw their helicopter spinning. We want to do multiple trials for validity. I typically have my students do 5 of each, so I'm going to have them drop the helicopter 5 times from their chair, watching the way that it spins, and marking it on their lab sheet. And then we're going to change the blades and do the same thing again. And so when I have my X up or my black dot up and my Y is pointed down, I'm noticing that my helicopter is spinning this direction, which is counterclockwise. If I flip my blades to where my Y is up and my X is down, I'm going to do 5 more trials this way with my students, and they're going to see that it's now spinning clockwise. And so you can have students start to formulate ideas about why it does change direction. You can even have them go back to their hypothesis, and we encourage students never to change their hypothesis to make it right. It was your guess to begin with. You're just going to analyze if it was correct and why, or if it was not correct and why. So you can have them analyze their hypothesis and then talk about the things that they needed to set constant in this lab. Have them identify the independent variable, what they changed on purpose, so the folding of the direction of the blades, and the dependent variable, which was which way the helicopter spins. And there are some conclusion questions to help students do this. There is an extension activity with this lab, and it's mentioned in the conclusion and analysis questions. There is another experiment that you can do where students will add paper clips to their helicopter to determine if that added weight makes the helicopter stay in the air longer. So to do the extension activity, you'll also need paper clips and a stopwatch. And this allows students to take their application of the scientific method and understanding the difference between independent and dependent variables, how to form a hypothesis, identifying a problem, and everything that you've talked about with the scientific method into another step that they can have a little bit more freedom with experimenting with.